Hello everyone, welcome to the Security channel. In this video, we are going to talk about 5 integrals. These are from the qualifying round of 2014 Integration B. Let's see what we are going to solve here. For the first problem, we have the integral of 3x squared times x to the power of 3 minus 1 to the power of 4 dx. Remember, we are going to talk about 5 different problems. Some of them can be easier, so if you know how to solve the first problem or the second problem, bear with me and you're going to see some good problems too. Let's focus on this one. First of all, we have x squared, then we have x cubed minus 1 to the power of 4. How we are going to use replacement to solve this? To solve this, I'm going to use a new variable like u for x cubed minus 1. If we get the derivative of both sides, we will have 3x squared dx equals to du. Now we already have 3x squared dx there. So at the end, we will have the integral of u to the power of 4 du, which results in u to the power of 5 over 5 plus a constant c. If we use x cubed minus 1 for u, then at the end we will have power of 5 of x cubed minus 1 over 5 plus a constant c. And that's our final answer for problem number 1. For problem number 2, we have the integral of x over radical x squared minus 1 dx between square root of 2 and square root of 5. Let's see how we are going to solve this one. To solve this one, I'm going to start using a new variable for what I have for the denominator. If we use u for radical x squared minus 1, and then if we get the derivative of both sides, we will have du equals to 2 times x dx over 2 times radical x squared minus 1. Now after some simple algebraic manipulation, the whole integral is going to be the integral of du, which is basically u plus a constant c. So at the end, we need to evaluate radical x squared minus 1 from radical 2 to radical 5, which is basically radical 4 minus radical 1, which is 1. And that's our solution here. For problem number 3, we need to evaluate the integral of sine squared of x over 2 dx. Let's see how we are going to do this in the next part of the video. To evaluate this integral, I'm going to use an identity. To simplify that, I wrote a few of them here. The one that I'm going to use is basically sine squared of x equals to 1 minus cosine of 2x over 2. If we do this, then the integral is going to be the integral of 1 minus cosine of x over 2 dx. Now I'm going to split it into two integrals. The first one is easy. It's integral of dx. For the second one, I need to evaluate the integral of cosine of x dx. And we already know that it's going to be sine of x. At the end, and after applying some constants, then I'm going to have 1 over 2 x minus sine of x over 2 plus a constant c as the final answer. For problem number 4, I need to evaluate the integral of dx over x squared plus a squared for a constant a. Let's see how we are going to solve this one. To solve this, I'm going to benefit from a well-known integral here. The integral of 1 over 1 plus x squared dx is equal to inverse tan of x plus a constant c. Now I'm going to convert what I have to what I know here. Let's take out x squared first and then use u for x over a. If we do this, then dx is going to be a du, and using some manipulation we are going to end up with 1 over a squared, the integral of a du over 1 plus u squared. We can write it as 1 over a inverse of tan of x over a plus the constant c. For the last one, I'm going to evaluate the integral of a fraction. We have 3x minus 2 over 2x plus 1, and we are going to evaluate the integral of this fraction dx. Let's see how we are going to solve this. To solve this, I'm going to take out a fraction here. I'm going to take out 3 over 2, then we will have the integral of x minus 2 over 3 over x plus 1 over 2 dx. Now to find this integral, I'm going to try to split it into two parts. To do this, let's use x plus 1 over 2, which we have for the denominator in the numerator as well. And then I need to subtract 7 over 6 to have negative 2 over 2. Now I'm going to split it into two parts. The first part is easy. For the second part, I need to focus on what I have for the denominator. Let's first multiply both top and bottom by 2 and then focus on the integral of 1 over 2x plus 1 dx. To find this, it's actually very easy. We just use 2x plus 1 equals to u, and then du equals to 2 times dx. Now replacing everything that we have here, you can verify that the integral of dx over 2x plus 1 can be written as 1 over 2 ln of the absolute value of 2x plus 1 plus a constant like c. Now let's go back to the original problem. To continue solving the problem, I'm going to just replace what I found and then doing some simplification. At the end, I have 3 over 2 times x minus 7 over 4 ln of absolute value of 2x plus 1 plus a constant like c. And that's our final answer. Thanks for watching the video. If you would like to see more puzzles, math involved activities, and problems from different math competitions and Olympiads, please subscribe to this channel. This is the SQRT channel, and I hope to see you in the next video.